Hello. So now I want to tell you about the natural deduction method in sentential logic. So the fundamental task of formal logic is to be able to identify arguments as valid just because of their structure, because of their form. And some arguments are valid just because of their sentential structure. In other words, because of the way the premises and conclusions are composed out of smaller sentences using connectives, expressions like if then, and, or, if and only if, and not. Sentential logic is able to establish whether an argument is valid or not on the basis of its sentential structure. And one of the methods that logicians have invented for doing this is the truth table method. So, in fact, it's really the foundational method in sentential logic. So, if you take an argument structure, a set of premises and a conclusion, just focusing on how they are built up out of smaller sentences using connectives, you take that argument pattern and you put it on the top of a single truth table. Okay, so you create a truth table with all the premises listed at the top and then the conclusion, and then you fill out you put in the truth table all the possible combinations of truth values of the sub-sentences in those premises and conclusions, and then you calculate the truth value of the whole, each premise and the conclusion on that same truth table. If on every row of that truth table, where all the premises are true, the conclusion is true also, then you know that that argument form is valid. In other words, it's impossible to have an argument that has that structure, which has true premises but a false conclusion. The conclusion actually follows deductively from those premises if the argument has that structure. On the other hand, if you do the complete truth table for such a sentential argument structure, and there's at least one row of the table where all the premises are true but the conclusion is false, then you know that argument structure is invalid. Okay, you know that it is possible to create an argument with a structure where the premises are true but the conclusion is false, so it's not a valid argument structure in sentential logic. Okay, so unfortunately, however, the truth table method is actually quite inefficient. Okay, especially if you're dealing with an argument structure that's very complex, and especially if it uses many different distinct sub-sentences as components in the premises and conclusions. If the argument is complex and has many different sub-sentences, the truth table just gets really big and complicated, and it's a lot of work. Okay, and a lot of the work is actually sort of unnecessary. Okay, so logicians have invented more efficient methods. Okay, and one of the methods is the natural deduction method. Okay, so it's called the natural deduction method because it's natural. In other words, it follows patterns of reasoning that we use all the time in everyday life, so it's natural to us. And it's a deduction method. In other words, it establishes that an argument pattern is valid by deducing the conclusion from the premises by a series of valid inferences. This method is very useful because it's a very useful thing to learn, because First, because it helps you be familiar with certain simple patterns of inference that are valid. And that's very useful to know, because when you recognize that, you recognize somebody else making an inference, and you recognize that it matches one of these valid inference patterns, then you know immediately that the inference they made is in fact valid. You know that the conclusion they drew does in fact follow from the premises they were inferring it from. So that's very useful. It's also very useful to know, be familiar with these valid argument patterns, because you can use them yourself, right? You can, in your own reasoning, use these inference patterns, and when you recognize that you yourself are using these patterns, you know that you're not making a logical error. You know that the inferences you're making are valid, and the conclusions you're drawing really do follow from your premises. The other reason why the natural deduction method is very useful is because it gives you the experience and the example, and helps you learn how to really prove something starting from a body of information. It teaches you how to start with some evidence, some things you know, some information you have, and on the basis of that, by a series of valid inferences, prove that something else must be true too, that this other claim is true as well, given that body of evidence. So the natural deduction method basically works like this. I'll give concrete examples in the next video, but it basically works like this. You have a certain argument that you want to establish is valid. In other words, you want to establish that a certain conclusion follows from a body of a set of premises just because of their structure. Okay, or put it another way, you want to establish that a certain inference pattern is valid. So what you do is first you make a numbered list of your premises. 1 period, and then write out your first premise. 2 period, write out your second premise. However many premises you have. And then from those premises you make a series of inferences. And you make sure that every inference you make is valid. And the way you ensure that each inference is valid is by only making inferences that follow certain patterns that have already been proven to be valid. Okay? So the natural deduction method starts with a set of valid rules of inference, they're called, that have been proven to be valid using truth tables. Okay? So you're given a set of valid inference patterns. And so when you're doing your deduction, you're making your inferences, you make sure that every inference you make fits one of those patterns. So every inference is valid then, demonstrably valid. And then you make your inferences until you end up with, as the last line of your deduction, the conclusion that you're trying to prove. Now, if you're able to do that by a series of valid inferences following these valid rules of inference, that proves that the conclusion follows from the premises. Okay? It's impossible to, the reason that proves that is because of this logical fact. It's a logical fact that valid inference, or entailment if you will, is a transitive relation. In other words, if from B you can validly infer if from A you can validly infer B, and from B you can validly infer C, and from C you can validly infer D, then you can validly infer D from A. D really does follow deductively from A. Okay, so you start with your premises, you make a series of valid inferences that you know to be valid because they match the rules of inference, and you end up at the bottom of your list of statements with the conclusion you're supposed to prove. that proves that the conclusion really does follow from the premises. You've just deduced that conclusion from the premises. So I'll give you concrete examples in the next video.